Welcome to Breakfast with Arup. It's our 53rd talk. So my name is Farah and I am the Marketing and Communications Leader for Buildings London. And so to our speaker. Born in London to an Italian mother and English father, Carolina's grandmother was an artist from Naples and her English grandfather was a Cockney plumber. With this vibrant mix of heritage and culture, it is little wonder that Carolina fell into engineering coupled with her love of the arts. At secondary school, a former Arup engineer, Jane Wernick, visited during the careers fair to give a talk and spoke about beautiful yet functional tensile structures. Jane's words chimed with Carolina, then aged 14. Deciding to study engineering, she duly went off to Cambridge, as you do. Whilst her degree at Cambridge was of course technically challenging, as you would expect, Carolina felt there was another aspect to her studies which could be further explored. She gained an impressive Fulbright scholarship at Harvard University where she studied design, a fantastic course which combined design and theory. The university accepted Carolina knowing that while she would not study to become an architect, she had a genuine love and passion for design. Completing her studies, she duly went off to work for Atelier One and subsequently ran an office in Melbourne for the practice. Carolina joined Arup in 2001 and has since worked on a stunning array of projects with a number of amazing architects, including the designs of the Serpentine Pavilion with Rem Koolhaas, Beirut Terraces with Herzog and de Meuron, the UN Studio designing Raffles Tower, and more recently Sky Central with PLP Architects, and more recently the V&A Exhibition Road Quarter with Amanda Levy Architects, which is opening in June. Carolina also lectures at the Architectural Association. As we've worked to prepare this talk together, Carolina has also confessed to me that she has a habit of breaking anything which is remotely technological, and therefore we've not allowed her anywhere near the Mac this morning until now. So it really is my pleasure to introduce the wonderfully talented and the self-deprecating Carolina Bartram. Thank you, everyone.
Thank you, Farah, and good morning, everyone. So this talk, as Farah said, has come out of my continuing fascination with technology and our relationship with it. So this started with my design thesis at college. Yet whilst I've been researching this talk and discussing with various people, including Farah, we realised how much this topic intertwined with quite a lot of other breakfast talks, and it's clear that it's a fascination that many of us share. When I studied engineering, it was very much an education in pure science and its technical application, and it was only later when I studied design that I began to formally consider the cultural and humanistic aspects of that technology. I studied design in the States, and there were definitely two schools of thought in the 90s. So the first was modernism. Theory and design in the first machine age was obligatory reading, and the history and philosophy of modernism, of a rational architecture, emphasizing innovation and exploration, sat very easily alongside my background as an engineer. And it also chimed with many of the notable buildings that had been built in London during the 80s and 90s. However, on the other side were the architectural theory courses, and these were taught very much from a postmodern perspective, looking at books such as Learning from Las Vegas and the study of semiotics. So we were encouraged to question what we designed in terms of the concept of connotation, so how cultural meanings can be attached to words, symbols, and designs. And this led me to question how we mediate our relationship with technology and how this is reflected in our urban landscape and in our buildings. So my master's thesis looked at modernism through this lens and was entitled, rather pretentiously because I was in my early 20s, The Image of Technology in the 20th Century Avant-Garde. I think we all have quite a complex and difficult relationship with science and technology, and it's related to our wish for things to be understandable and our fear of the unknown. In particular, I think we fixate on the idea of man trying to act as God or being too curious, and the rest of mankind being punished for it. So you think of Pandora's box even. In terms of technology, the Industrial Revolution was the great tipping point. And Mary Shelley's Frankenstein is the first real piece of fiction that deals with the man of science. Amazingly written by a 21-year-old woman, it's one of those key works whose central idea continues to fascinate us. So every time some technical or scientific innovation has emerged, we have used the term Frankenstein to describe it. So this has been from the 1920s, when we had chemistry and gas, especially in the light of World War I. In the 1930s, it was medicine and penicillin. In the 1950s, it was nuclear. The 60s and 70s, think of DNA and test tube babies. And of course, now we have artificial intelligence and things like genetically modified crops. Now, Frankenstein was a Gothic novel, but science fiction in books and films also plays on this fear of technology. From 1984, where we have computer surveillance ruling our lives and curtailing free speech, to 2001: A Space Odyssey, where HAL, the computer, turns on the humans to try and save the mission. But science fiction also reflects our dreams and our hopes of where we believe technology will help or save us. And so, for instance, Mark Twain wrote about something sounding very like the internet in a short story titled From the London Times in 1904, which he actually wrote in 1899, reacting to the birth of the telephone. And taking this thinking forward, we have Star Trek, maybe giving us the inspiration for the modern flip phone. And we have flying cars in Blade Runner, and less seriously in The Jetsons. And clearly, these are precedents for this flying taxi, which many of you might have seen in the news last week, which had its test flight and is being developed for release. I think nowhere do we see this dichotomy of fear and wonder more than in our view of robots or artificial intelligence. We want to create something that is perfect and in our image, and yet we want it to be our slave. So we have the replicants of Blade Runner, who are threatening and have to be hunted down, or we have the cute, subservient robots from Star Wars who save us and help us. To me, the study of the evolution of science and technology is interesting because this has always brought about fundamental changes in society and culture. The Industrial Revolution, of course, had a huge impact on society and on our built environment, from the rapid swell of urbanization and the introduction of the factory job. Yet I also find interesting the slightly lateral, unpredictable changes that technical advances bring. So, for example, the expansion of the railways during the Industrial Revolution suddenly meant we had to have universal time. Until the era of railways and train timetables, if Liverpool was 20 minutes ahead of London, it didn't really matter. At that time, most people didn't own watches or clocks, and they were guided by sunrise and twilight and sunset. So before railways, time had sort of been elastic. But these were, of course, times of great change and unrest. The discussion of how people fitted into this new world can be seen in this image. It's almost as if people were part of the machine. And so an integral aspect of the Industrial Revolution was the development of workers' rights and workplace practices. But many designers were also excited and inspired by the speed of technical change. And this image is by the architect Santelia, and it's of the city in the early 1900s. And to me, it perfectly captures that optimism and that race to embrace the new. So now we're in another revolution focused on information and digital processes. Email and social media have blossomed. Nearly every electrical and even food product that we buy has been partially produced or touched by a robot of some sort. And algorithms, such as Google searches, are changing the way we interact with each other and with the world. We have all experienced how countries and people have responded to the impact of globalization. So what will the other changes be to our lives, and especially our working lives? So a recent Oxford University study predicted that 35% of all current jobs will be lost to automation in the next 20 years. We're living in another age of speed and unrest, and again we are torn between fear and uncertainty, yet also finding that change exciting and inspirational. Modernism focused on technical change in a utopian way. The machine for living was a good thing that would simplify our lives. But as complexity of technical change increased, we could no longer comprehend this in a simple way. So many products and buildings tried to make technological complexity physically understandable. So rather like taking the back off an old watch and seeing the way the gears and mechanisms worked, for example, Apple Macs in the 1990s were physically transparent, revealing the wiring and the circuit boards. And Calatrava bridges gave people the illusion they could see and understand the forces flowing through the structure. However, I think with the development of digital technologies, we've turned away from the simplicity of those visual signs. And now our relationship with technology seems to be focused on controls and interfaces. So the use of tactile elements such as touchscreens on our phones and voice commands give us the illusion of control and understanding. With buildings, that element of command is achieved through the use of intelligent control systems and signage. Francesco Anselmo, in his fantastic breakfast talk, Good Morning, You Are a Very Clever Building, showed how far we can go to break down the interface with our buildings and made this very room we're sitting in talk to us. And this is happening now in our buildings, helping us to make our life seem simpler. For example, things like intelligent fire signage and analysis can help us replace standardized rule-based systems, and it can make the building tell us what to do in the case of an emergency. So where are we heading? Well, the Industrial Revolution was about mass repetition, and the archetype was Henry Ford with his any colour so long as it's black. And one thing I think has changed and is still changing is that we're moving now instead to an era of mass customization. So making technology individual somehow makes it relatable to us. So this can vary from buying a personalised car, a long way from Henry Ford's original idea. Or it could be as simple as arranging the apps on your phone in the way you want them, in the way that's simplest for you. Or, changing your screensaver or buying a phone case. It can also be more complex. It can mean creating your own technology with hardware like Raspberry Pis or using open source software. Since I started my career as a structural engineer, there have always been people pushing for buildings towards that Fordian dream. However, most buildings we're involved with, outside of mass housing, can be seen as prototypes, individual and probably unique. There are, of course, repetitive products in every building. However, the building itself is not a product. And recent advances in off-site prefabrication and modularized systems have meant we have been able to come very close to achieving a greater level of repetition and production line efficiency. However, we now have the ability to properly customize our buildings using processes such as additive manufacturing. So it's up to us to discuss how much customization is a good thing for buildings, especially in terms of future flexibility and longevity. We're also using robots, for lack of a better word, in an understandable way, to take humans out of dangerous situations or to control tasks either requiring great accuracy or requiring great repetition. So we've used robots, for example, to fabricate a wood chip barn with the Architectural Association Design and Make facility at Hook Park, and this is the final building. In mining, something like automation works because the mining machines are handled remotely by an operator. There's not a great saving in human time, although there is an increase in efficiency, but there is a huge reduction in risk to life. So will robots make it onto building sites? And is this something we want to see, and is it desirable? Right now, the expense is probably too great, and the benefits probably don't outweigh the costs. Another big shift we've experienced is the use of intelligent systems and techniques, digital media and artificial intelligence. We have AI that can beat us at complex games such as chess and now even bridge. And as Giulio Antonuto in his breakfast talk told us, there is AI that can write a simulation of bark that is better than humans' version. In construction, we have fantastic optimization tools that can be used to sift through data and optimize to achieve a desired solution. So what's really exciting is the way we can now use these tools in the building industry. For example, the V&A has allowed my colleagues to remotely access the BMS, and we're using techniques that have been used previously in the energy industry to allow the BMS to predict what may be required and adjust the controls, including humidity, to optimize energy use. This system is predictive, it's not reactive. So the next step will be a BMS that independently learns and tests how your building operates over 6 months, and then begins to optimize the controls itself. In a similar manner to the way, as Farah told me, Google now predicts that she is going to yoga every Saturday morning, even though it's not in her diary, and then it tells her how long it's going to take her to get there. And the question for me, especially as a structural engineer, is where will this go for us? What will it take to achieve, intelligent structures that can maybe react to force? But it can still be said that most AI is still narrowly intelligent and task-based. So the big developments and investigations that are happening in this field are to try and make machines which can learn from one thing and then adapt that generic learning experience to apply it in another different non-related task, as we might do. And also to explore whether AI can be truly creative, AI that does not imitate Bach, but that has the creativity of Bach. It's one of those facts that come up in science programs that the human brain is probably the most complex entity in the world because of the billions of connections between neurons. So if AI and optimization rely on our initial input or programming, how can you replicate or mimic that level of complexity? And especially in terms of design, how do we input and factor in all our cultural, historical, tactile, and emotive responses to buildings? So Sophie Labouva reminded us of how important this aspect is to our relationship to our buildings when she gave her talk, "When was the last time you touched your building?" And to prove our point, that's what happens when you put 5 structural engineers in front of a beautiful concrete stair. A lot of research has been done on the way people think. This shows we have 2 ways of thinking, the intuitive fast mode and the logical slow mode. Research has shown that the first mode, the instinctive one, sometimes makes the best decisions. And in a way, we all know this from our work. So when we worked on Sky, the timber roof has at least 6 perfectly rational reasons for why that design is the best design, which it is. However, a key reason was also the fact that the team really wanted to use timber against the main concrete frame. And when the roof was built, all sorts of people, clients, designers, contractors, commented on the beauty of these 2 materials together. So sometimes logic is not enough. We need buildings we can touch that work with our memories, our emotions, and our histories. And these difficult subjective issues are, I think, why crafts survived industrialization. Imperfection is not necessarily a flaw, and it can make things more easy to relate to and more understandable. The hand sketch can sometimes communicate more than the BIM model. So to go back to history again, when Rembrandt took up the relatively new form of etching, may I say, mainly as a way of making a kind of fast buck, he took the technique of engraving a design into copper and he began to treat the printing plate like a canvas, leaving some ink or tone on the surface of the printing plate in order to create painted impressions of prints. So he had the advantage and the speed of the technical process, but he had the touch, the spontaneity, and the individuality of a great work of art. So now that we're using 3D printing and robots, what can this mean for us? For me, the loss of the handmade or even the semi-handmade is to lose knowledge. We can't understand materials unless we work with them. And this was also a key concern of modernism, despite its industrial roots. If we leave everything to robots and AI, we lose that connection and any depth of understanding. And to me, that's a problem, although I also recognize that mine is quite an emotional response. And it's partly due to the fact that I'm quite passionate about making, as are most of the structural engineers I know. So how do we integrate the 2, the handmade and the digital? I think that AI and digital processes are very useful when they work with us. So for instance, medical diagnosis is helped by artificial intelligence. The AI is very good and fast at processes like pattern spotting, so it's excellent at things like diagnosis. And yet the human interface is still required, not least to deal with communication, to ask the right questions, to check the diagnosis and also question laterally and more instinctively when maybe things are not quite as straightforward as they may seem. One of my favourite projects at Arup, which wasn't mine, is Rock on Another Rock, an installation in Hyde Park with the artist Fischli Weiss. This employed high-tech processes, LiDAR scanning, 3D printing, 3D finite element analysis. But these worked alongside and to aid the very simple techniques of handling models and looking for the best visual and structural configuration. And you ended up with this kind of slightly gravity-defying, but very simple result. Similarly, with buildings, we need to find intelligent ways that still deal with softer issues such as tactile and beauty, yet fully use the potential of digitization to help minimize mistakes and increase efficiency. So a final question is, how will these digital technologies change the way we work? Well, from my recent experience on the circular building, which we built last summer, I believe it really only works if you have everyone around the table to create a more unified construction process. You have to have shared models and processes. The pattern of responsibility will also need to shift if designers are effectively creating things for robots to build directly. Our ultimate fear is that we create a conscious artificial intelligence, like the replicants in Blade Runner. So many scientists believe we are a long way from this, but there are people like Stephen Hawking and Elon Musk who are advocating the need to control development, and there is a convention of 23 guidelines that developers in the field are beginning to sign up to. Harari, in his book Homo Deus, suggests we may become part cyborg in the next century, still humans, yet using AI intrinsically to optimize part of us. And new technologies seem to confirm that this could be a direction we may head to. Those of you who saw the news report of this man who has a prosthetic arm that he moves by thought will probably be as amazed as I was. These are things that are unthought of, except probably in science fiction. And for those of you under 40, this is the $6 million man. As humans, we have an ability to adapt and evolve. In the past, most of our terrible fears with regards to technology have not transpired, yet many of our utopian dreams have become true. Life after the first industrial revolution has generally become better for people. As technology continues to unfold, I believe that we will find ways of harnessing these opportunities. These technologies can bring huge advantages, not always in place of, but alongside more traditional ways of doing things. This is the time to embrace technology and help shape where it will lead us. There are significant ethical and legal decisions which will help safeguard our future and where we're heading. But we've negotiated these in the past, not always seamlessly, and I expect it's going to be the same now, especially given the speed we're going at. But when Tim Smith came to Arup a few years ago, he finished with this phrase, and I want to finish with it too. So I think it's a great time to be a Homo sapiens. Thank you. Questions? Not difficult ones?
With the 3D printing aspect that you talked about, obviously we've seen, and they've now kind of built really small-scale houses and that sort of thing with 3D printing. But from a more complex structural engineer's point of view, is there a bigger scale that 3D printing kind of take on, do you think?
I mean, I was showing the joints there, and I think that's quite an interesting place to be because you don't necessarily need to customize the whole of a building, like you don't have to customize the whole of a car. And often joints are the things that are most individual. So it gives us a lot of freedom if we can take that complicated thing and make it, use a simpler way of making it than some guy trying to sort of hand measure up, sort of welding and things like that. So I think I would use it more in a limited but intelligent way in a way. So let's not print a whole building, but let's use it and target it in the places where we can get the most from it.
Just to follow up on this question, do you think it would be feasible to prefabricate and print them somewhere off-site and have a manufacturing plant which can possibly replace creating steel junctions but 3D print them and supply all the construction sites with these junctions?
I think you could, definitely, and that's kind of what's been looked at. I don't know whether it ends up being a specialist. I mean, at the moment, it's more done with universities, so it's how the industry are going to pick up on these and begin to develop them, whether the steel industry picks up on it or whether it's an independent kind of firm that does that. But I think that's definitely the ideal, for sure.
If you had to make some predictions, how would you say that the technologies that you've talked about today will affect the sort of spaces that we use every day, so the home and the office? It's kind of an open question.
What I'd like to see is kind of that I think what's really interesting is we have really sort of quite complex ways of analysing and controlling buildings now. And actually, in some ways, they could make things simpler. So it could, a bit like I was talking with things like fire signage. That was based on Sky, where we took out a lot of the fire compartmentation within the building and are using fire signage instead to guide people where to go. So actually, it's made the building a lot simpler for people to use. So I think for me, it's that kind of step to actually use tech to actually simplify and to aid, rather than making things necessarily more complicated in buildings. I think there's enough complication. And probably, although I talked about mass customization, it's probably going too far to think I could sit in my office space and everyone has a different, say, control to the temperature and things like that. Although I would love that, because I'm always the cold person in the corner. But that might be a way people want to try it. But so it's quite clever. And I think a building that could learn is a scary but interesting thought.
Just thinking about the sort of educational element of this. If the trouble with AI is that it's not very imaginative, then it seems likely that the first skilled jobs it would take over would be the ones like engineering, the structural engineering, things that have that require knowledge of force and understanding of how things interact, but perhaps less imagination. And do you think, therefore, we should be training fewer engineers and focusing more on courses like art or design or architecture, more imaginative courses to be ready for that new work stream?
You can't say that. I think we will have a different, of course I'm going to say I think you always need engineers, because there are always multiple options open, and you have to part of our role is assessing the appropriateness from this multiplicity of options. And I think in a different way. I mean, Peter Rice made this differentiation between he sort of said we had ingenuity rather than creativity, and it's a kind of way of coming at things sideways. But I think what will happen is we'll automate certain parts of our processes, the things that are more repetitive. And that's a good thing, because it'll stop us making mistakes and things like that. But that first input and those first discussions around a table, I don't think you're ever going to recreate. I think the bigger impacts maybe for the construction industry is, where we go. I mean, when you look at things like the mining that I talked about, they're losing manual jobs to computer jobs, and that's quite a big impact for, sort of the societies or the little communities where mining exists. And I suppose it's sort of thinking, are we always pushing people away from doing work with their hands towards doing work around a computer, and is that going to be a problem for us somewhere? So there's a kind of bigger picture, I think, as well. Does that make sense?
Have you thought about how climate change fits in this picture of the future?
I'm hoping I haven't kind of specifically, we're always working with that in the background of our heads, that climate change is so we should be making buildings and communities where that is one of the things that we're optimizing and dealing with. Probably, beyond that.
I guess the question is, the more technology we create, the more we the more we produce, the more we...
Well, that's kind of on the, on the iPhone. You get your new iPhone every 2 years. And I think come to listen to Richard in a month's time about the circular economy. I think there has to be a shift with that. And I think that's also why, things like the Raspberry Pis and where you're kind of making your own. And there are now cell phones that, although they're not as sort of efficient as things like the Apple phones, that allow you to kind of customize and plug in and change so that they have less redundancy. But in a way, it's also a social thing. If you didn't care that your iPhone wasn't the newest model, you wouldn't go out and buy it so it's a cultural shift we have to make as well.
I'm going to steal a question from my friend here. If 35% of people's jobs are at risk here, is a shorter working week a solution to all this?
Well, people have put that forward before. I've been listening to a lot of Radio 4, I have to say, in preparing for this. And because they have great podcasts on science. And quite a few people were saying, yes, this should be leading to us not working, you know, a ridiculous number of hours. Although the idea is less that 35% of current jobs will be lost, but of course there's the fact that, you know, an X% of new jobs will be created, servicing the technology, or will have a shift, just as you can think of, you know, all the jobs in sort of Google, Facebook, all of those people, you know, 20 years ago just weren't there. So there is this kind of shift in jobs that will continue to happen. So although I'd love to think that we were doing it every day, I'm not sure it's in ours to make ourselves do it.
I thought it was really, really interesting, particularly looking to the future. Like one of the key things I picked up on is the fact that 35% of the current jobs might be outdated or taken over by automation. And I think that has a place in the building industry with the robot-built house. I think that could be implemented in the future for sure. It just stops people getting involved in dangerous situations and allows for a safer construction. So I thought that was particularly interesting.
I think there's two aspects to it. Obviously, as a developer, you need to look at ways in which technology can help you. You know, as I presume another developer in there said, you know, have more certainty around costs, you know, at an earlier stage, which is something that everyone aspires to do. Obviously, therefore, drive efficiency in your, you know, underwriting of a project and ultimately make it a more financially viable project. Then there's the value creation side for occupiers. So if you look at buildings like The Edge in Amsterdam, that is using technology to obviously drive value for the occupier and ultimately for the developer, because, I mean, that's a bit of a specific example, but if you could do something like that in more general terms of the buildings, really people should pay higher rents and, you know, offer them lower incentives to take the space. So it's really about not overcomplicating it, I think, to a point where people are scared, as we saw in there, and, you know, put off by the technology, but, you know, where it's valuable for both the developer and the end user. And if we can't do that, then, you know, just scrap it all and go back to typewriters and candles.